Hello and welcome to week 2 of the first ever CAS Virtual Showcase. You have joined the final webinar of the day entitled OHBot Robot Heads for Computing. This webinar is part of the CAS Virtual Showcase, which is a 2-week window of webinars designed to support the CAS community. I'm Wendy McLeod and I am the CAS Community Outreach Manager for communities across London and the East of England. Joining me this afternoon is the presenter of our session, Dan Warner. OHBot are a UK-based robotics company who have been making educational robot heads, software and resources since 2015. OHBot's educational robotics system has been designed to stretch pupils' computational thinking and understanding of computer science. During the session, please use the question window on the right-hand side of your screen to ask questions. All attendees are in listen-only mode. The top of the window has an orange rectangle, which can be expanded or collapsed. If using social media, the hashtag for the event is hashtag CASVirtual20. I'm now going to hand over to Dan for the session.
Hello. Hi, my name's Dan Warner, and yeah, it's lovely to be here. And I run a small business called OHBot, and we're based in Stroud, Gloucestershire, and we make programmable heads. So my background is that I was a teacher, and then worked in a local authority helping schools with ICT, and then started developing these. And the starting point really for it all was a meeting that I had with I'm just going to try and change this slide here. A meeting I had with Matt Walker, who developed a robot head that was a receptionist in King's College, and this was over 10 years ago now. This robot head was in the entrance hall to the college, and it greeted visitors. It was what we call a behavioral robot. It had particular behaviors, and if you went in there, it would sometimes help you, and sometimes if it was feeling grumpy, it wouldn't help you, or it might make a comment based on the color of the clothing you were wearing or something like that. So it was there in the college for 10 years, and I met up with Matt, and we had the idea of a programmable robot head. So this is where OHBot came from. And if I show you, one of the real inspirations for it was what we were seeing in schools at the time. And actually, at that point, there was really only one robot you could find in every school, and that was one of these, or something like one of these. And this is the original Valiant Turtles and Roma and B-bots and so on. And these were fantastic robots, and you know, they've been trundling around in our schools for years. And one of the things that was interesting for me was that you know, all of the outcomes for these were around maths, or generally around maths. And so they were drawing shapes, they were perhaps drawing pictures, perhaps they were routes, or going to different locations or routes. So they were largely maths in outcome. And what I was interested in was whether we could develop something that would allow children to have outcomes to their programs that would be that might be to do with text, and to do with expression and human-like behavior. And so that was the starting point for OHBot. And you can see that we've been busy. These are some of the stages in developing OHBot, and from something that was made from bits of cut out plastic, stuck together through early prototypes and through to the OHBot that we have here, and you can see here. And so now we have OHBots, and we make OHBots available via our website. And before you all turn off and think that there's nothing you can do unless you have an OHBot, I want to point out that we've got an app that allows you to program an OHBot without having an OHBot. So this is completely free. So today in this session, you might want to have a go at following along, and you can. There's an app that we have that's available that allows children to program the robot by arranging blocks. So this is modeled on Scratch, and it has, as you can see here in the red circle, there is a simulation. So you can develop programs and debug your programs and see your programs, see what your programs do and debug them by using the app and seeing and using the simulation to do that. So that's one way you can join in with this. We also have Python libraries, so it is possible to program OHBot and Pico here using Python, and just recently we've added Scratch into that, so it's possible to use Scratch to program them too, although both of those are without a simulation at the moment, so you can't use those unless you have a physical robot. So the focus for this session really is going to go through how the robots work, and then I plan to do some live coding. I hope this works okay. I'm as you can probably tell, a little bit nervous about this, but I'm hoping that we'll be able to do some live coding and you'll be able to see the screen and see how we can create a program that will directly control the robot. So I'm going to just introduce the robots now, and I just leave this over here for now. So this is OHBot. It's a robot that has 7 motors, so it's able to turn its head left and right, and you can put it to any position in between. It's able to tilt, so it can nod up and down, it can look up and down like that. It also has eyes that turn, so its eyes turn left and right, just like that. And up and down, so it can tilt and turn its eyes. And it also has an eyelid. It's important for a robot to be able to go to sleep, perhaps. So you can open and close the robot's eyelid. And then it has 2 motors for its mouth. And actually, some of the early robots, versions of OHBot, only had 1 motor, and we couldn't make it smile or frown. So we added 2 motors for its mouth. And so if you put both of them down like that, we have a smile, happy robot. And if I put both of them up, we have an unhappy robot. And so yeah, one of the really key things about OHBot is that it is expressive, so it's able to express emotions through the robot. So and Pico here is a small version of OHBot. We've just released Pico. It's a mini version of the same thing, and I'm just gonna, this is a bit risky for me, but I'm going to switch over between them just so you can have a little look at Pico, because Pico does very similar things. And I'm just going to swap this over so we can see Pico. Sorry. Pico. Pico's lights are a little bright, so I'm going to turn them down. Hoping this will work. There we are. So yes, Pico does the same thing. So it can turn left and right, and it can look up and down like that. And it has pupils that turn like OHBots do. So we can look left and right, and we can look up and down, and we can blink.
Dan, I wonder if you could do the demonstration again, but if you stop sharing your screen just to make it a lot larger, so I think the audience could see a bit better.
Yes. Okay. Yeah. Certainly. Hang on.
That's fine. There we go. That's perfect.
Okay. Sorry. Yep. Okay. I'll go from the Pico. Pico is here. So Pico has 3 motors, and so it's able to. Oops. It's able to turn left and right, and it's able to look up and down, and it can turn its eyes left and right and move its pupils up and down, and it can also blink like that, and it can smile and frown. And of course, one of the things about this is that the robots are able to move all of their motors at the same time too. So in fact, I'm just controlling it there on the mouse, but you can see we're able to control the robot using a program there that is just sensing the position of the mouse. So that is the hardware, and it connects directly to a computer. So it's not they don't work unless they're connected, but anything you program appears immediately on the robot. So it happens straight away. It doesn't need to be downloaded or compiled and downloaded. It runs live. So what I thought I'd do would be to share my screen, and I'll show you how the robot can be programmed to move. So using the OHBot application. So I'm just going to swap back to OHBot for this because I think it's a bit easier to see because it's larger. And I'm going to start sharing my screen again on here. Enough. There we are. So I'm just going to go through a sort of a sequence of little programming activities that we could do to get started, and hopefully it will illustrate how you can program human-like behavior with this. So this interface it runs on Windows. Although it looks like Scratch, it's not Scratch, but we've designed it to be as consistent as possible with the way Scratch works. So and can be programmed. So I've added, in fact, I'm just going to drag an event block to start with, and I'm going to choose the down arrow, and we'll just get the robot to move its head. So you can see here there's a block for a set of motion blocks, and in Scratch these ones allow you to move objects around on the stage. In this we can set the position of any of the robot's motors, and so you can see there are blocks here for each of the motors to set the position or to change the position of a motor. And I'm going to choose this one here, and actually if I left it at this, and if I was working with a class of children, I think I would probably leave it at that and say, well, what do you think that's going to do when I press the down arrow? And I've got set, sorry.
So I was just going to say, is it possible to zoom in on the screen so to see the blocks slightly larger?
Yes, yes.
That's much better. Yeah.
Yeah. Oh, thanks. Yeah, that's good.
Thank you.
Yeah, so I've got so I might ask them to predict what that might do, and before running my code. And I'm going to run it now by pressing the down arrow. So we've got an event, which is when the down arrow key is pressed, set the head nod to, and I've got the number 5 there. And I'll just press the down arrow now. So I'm pressing the down arrow now, and you can see nothing's happening because, so this number here is setting the position of the robot's head, and it's currently in position 5. So if I run that code, nothing happens. So if I want it to move to a different position, I'm going to need to change that value between 0 and 10. And so if I'm going to try and get the robot's head to move down, I'll choose a different value and we'll see what happens. So down arrow. Oh, so actually that it's gone up. You can probably see what we need to do if we wanted it to go down when we press the down arrow. So if I press the down arrow, I've changed that now to 0, and I've changed the down arrow, and now it's gone down. In here, there's a button for resetting the robot. So this resets it to its starting position. And if I do this again, you can see the robot moves its head down. So we've got the very start of some control, physical control. If I wanted it to do something else, so at the moment we're doing everything, we're having to press the button to make it happen. If I wanted it to do it as a sequence of movements, then I'd need a few more blocks. So we could have a nod to make the robot nod down and then come back up. So now I've got, when the down arrow is pressed, set head nod to 0, which is what we had before, and set head nod to 5 as a sequence here. Now if I run this by pressing the down arrow, then you'll see again nothing happens, because we might talk about why that is. But a really important idea for children really is that this idea that with a physical device, things need time to move. So you need to give the motors time to move, and we've got blocks here that run in a millionth of a second probably, and so when the down arrow is pressed, as soon as this block runs to set it to 0, millionth of a second later, the set head nod to 5 block will run and set it back to 5, so nothing happens. So if we want to be able to see our robot moving between those two positions, we need to wait in between. And so now if I add a wait block, it should go down, wait for a second, and then come back up again. There we are. Each time I press the down arrow, it will do that. And of course, we could have a much longer sequence of movements, having it doing something more. For instance, looking around, let's get it to nod, and then maybe shake its head. Let's do a head shake. So I could have a few more blocks there in my sequence. And so now, after its head is in position 5, like where it was, we could have it turning. So the head turn motor works in the same way. So it goes again from 0, which is all the way one way, to 10, that's all the way the other way, and 5, that's in the middle. So I'm going to set it to go all the way one way, and then all the way the other way, and with a wait in between each one so we can see it. So now if I run my program, there we are. So we can create, sequences of movements using it. We can also look at behavior that goes on all the time. So using repeats in our program. So if I wanted, let's have a look at getting another motor to move. Let's have a look at the lid blink motor here and getting the robot to blink. And that might be something that we want to happen. We want to happen all the time. And so we'll keep with down arrow. and so for a lid blink, I might want to close the eye. So this will close the eye lid, and then wait for a second and open the eye again. And so now if I run that, we have a robot that blinks, but only once. So if we wanted to make it keep on blinking, then we can use a loop to repeat constantly. So we can introduce repetition into our program. And if I run my program now, well, let's have a look at what happens. You might want to think about what you think will happen. Let's have a look. It's maybe not quite what we expected. You can see here that in our loop, it closes its eyes, waits for a second, opens them, but then immediately closes them again. So we need another wait in here if we want our robot to blink. And so we've got a blink, and that could be running all the time. That's not a very realistic blink, perhaps. If we want to make it a bit more realistic, we can play around with these, and you can put, oops, knock something over, and let's try a much shorter blink. There we are. That's a little bit more realistic, but we could also look at, well, actually, what if it was, we could look at using a random in here that would mean that the robot waited between blinks. So now we've got a wait in here. It's quite a long wait, actually, 10 seconds, isn't it? That's probably not very realistic for a, let's try that a bit more. There we are. So we can use, repetition in our program to bring the robot to life. I mean, a really big part of OHBot is speech, and so we can make the robot speak by adding blocks, and we've tended to focus on text to speech, so that children can type in what they'd like the robot to say, and it will speak what they've typed in, which is often in the classroom is much easier to work with than recorded speech, although you can add recorded speech into there. But text to speech can be added, and so there in the speech block, in Scratch, I think the speech blocks add a speech bubble to the screen, whereas here they will speak what the robot, what's typed into that block there. So if let's do a different, let's just have a space key, and I'm going to add a say block. I'm going to say, hello humans. It's lovely to meet you. And so I've typed in what I want it to say, and I'm hoping this is going to work and that you can hear this, but I'm going to press the space key, and hopefully.
Hello humans, it's lovely to meet you.
Can I just check that you could all hear that?
Yes, we could. Yeah.
Yeah, you could. Okay, that's great. Okay, so we can have speech in our program, and we could have, we can have our robots speaking a number of lines or taking lines from a database, for instance. We can also change the voice that's used, and this is really important. We've made a point of not gendering OHBots at all. They're male or female, it doesn't matter, it's up to you. And so you can use a male or a female voice, and there are also voices in a number of different languages.
Hello humans.
So you can have OHBot speaking in French or Dutch or German, as you like, and those are available to use within it. So So we've got a voice now. At the moment, OHBot's lips didn't move at all, and that's because we haven't programmed it. We could have made it simple by adding a button in to make its lips move when you have speech, but we didn't. What we've done is to leave that up to you to program. And so there are various ways, and often when I'm working with children on this, they try and find their own way. That might be something like making it open its bottom lip before it starts speaking, and then close it afterwards. So
hello humans.
There we are. We've got the start of some lip movement, but there are ways that you can sense. There's a way we could add to our program to make it sense the position of those, the position based on the volume of the speech. So in here, in the sensing menu, there is a top lip and bottom lip block. And you'll see if I run this, I'll just make it a little bit bigger just in case you can't see it. If you have a look at those top lip and bottom lip values, those are variables based on the volume of the speech. So if I run my code.
It's lovely to meet you. Hello. Hello humans. It's lovely to meet you. Hello.
So those are changing as with the volume of the speech. And so what I could do is to add another bit to my program that will keep on. So I'm going to say when the green flag is clicked here, we're going to keep on setting the position of the top and the bottom lip motors to those sensor values there for the top lip and the bottom lip. And so as long as I've got my loop here running, if I just run my loop there, that should be sensing the volume of the speech and setting the position of the lip motors. So if I run that now, you can see.
Hello.
And so any other speech that I added into my program would also be synchronized. So we can do that in that way, and we've had children writing stories that the robots have performed. We've had them performing jokes, and we've had them, yeah, all sorts of opportunities for that. So the as well as making OHBot expressive using speech and movement, the robot can also be sensitive. So we focused on making it sense. And I'm not going to try and demonstrate the camera because I'm already using the camera. And I think if I started to try and put it in here, we'd have problems. But there are all sorts of things that it can sense on the sensing menu here. And I thought I'd show you speech as we've had speech generated. I thought we should have a look at making it respond to speech using speech recognition. So in the events menu here, I've got a block here that will respond when it hears me say the word listen. And so I could make it, in fact, I could just make it say something. Listen.
Hello.
There we are. So you can see it has triggered that listen. Listen.
Hello.
There we are. So there are a block we've got here, the ask and listen block, that will start so once we've got this started, we'll start listening to whatever I say. And so actually I could do something very simple like have it speak back what I've spoken, and you'll see then that we can so now just going to cheat a little bit and add lip sync onto this. Listen.
Speak to me.
Can you hear what I'm saying? I'm now speaking. I'm just wondering if you can hear what I'm saying.
Can you hear what I'm saying? I'm now speaking. I'm just wondering if you can hear what I'm saying.
There we are. So you can see that it will, I have to avoid saying that word now, otherwise it will start heckling me. And so you can see here that what I said came through as a block here. And I mean, I'm really excited about this because it means that children can start to work on speech recognition and working with the text from recognized speech. And so we could, for instance, let's get the robot to tell us the time if it hears me say that word. So so I could say here, well, if my answer contains the word time, then the time is, then the robot could say the time is, and let's have the time, so we can pull in the time here, the current minute and the current hour, and we can then speak those two. So if I have, let's try this now. So I'm going to try listen. Listen.
Speak to me.
I don't know what to say. I don't know what to say here. And listen.
Speak to me.
Can you tell me what the time is, please?
The time is 14:32.
Okay, there we go. So you can see that the where my answer contained the word time, it gave us the time. And so that yeah, so OHBot has lots of, I think it has lots of potential as a creative tool, and we've developed it very much as that. I have to stop that now, otherwise it's going to keep on doing it non-stop. And we've developed it very much in that light. So I think that's probably all I wanted to say really a bit about OHBot. It's you know, they are available. The website ohbot.co.uk has lots of information about them, and as I say, if you access the if you have a Windows machine, you can access the Windows Store, and there are and the app for Pico and for OHBot is available on there. Both of them have got a simulation, so you can use them without having a physical robot. So I'm very keen that everyone, you know, can have access. There's also a whole set of resources online that you can access that go with them. And if I just
mention that, Dan, because that was one of the questions I was just about to ask you. Sandra says it looks great. Any teaching resources available, please?
Yeah. So yes, we worked with a school in Slough that developed a scheme of work. So it was quite nice actually that we didn't do anything very much with this. That the school have developed a scheme of work for Key Stage 2 for OHBot, and we're just at the point of adapting it for Pico too. So that is available, and that's all freely available on our website. there are also a set of home learning activities for Pico that are available via our website, and we've done various projects we've done that are available, and you can have, there's a activity where children compose rap for an OHBot. We've had some really amazing rap performances from OHBots and so on. So there are a number of projects on there that can help with getting started. We also have an online sharing space called Obiverse that has programs that you can download and share via the website. So yeah, it's there's quite a lot there available to help. And we are a small company, and we're happy to help with suggestions and any advice.
We've got a few other questions. One person asked, does it work with the Mac?
The OHBot app doesn't at the moment. We'd love to have a Mac version of the app, but it doesn't. And it's just, the cost of development for us is really, really high. So the OHBot app doesn't, but you can program using Python on a Mac, and we also have for Chromebooks, Scratch would work. So yeah, it would be great. It would be lovely to be able to develop the OHBot app for Mac. We'd love to do that, but it's just the cost. Yeah, maybe one day.
Some other questions. One person asked, is it a browser app or an app for a tablet?
It's a Windows app. There isn't, so you could run on a tablet the Scratch, the version of Scratch we had should run on an Android tablet, I would think. But the app itself is a Windows app, so it's available via the App Store, which is and then you can if you just search for OHBot or Pico, you can access it from there.
Can you connect it through Bluetooth?
Not yet. We'd like to. Maybe next version. Maybe. Yeah, that would be nice. Not yet. No, it's only wire connection, which is I know it's low tech, but actually that has sort of worked quite well in classrooms because of the practicality of just plugging it in and it working. So no, it's not Bluetooth yet, and it won't run without the computer. It needs to be connected all the time in order to work.
Two more questions. How much does it cost?
Okay. We do them either as a kit. So OHBot is available as a kit or assembled. And we started off just making kit versions, and then schools started coming to us saying, we'd like them assembled. Can you assemble them? So we started doing them assembled. The kit is £139 plus VAT, and the assembled one is £179. And then Pico, we only do assembled, and is £99. And that includes all the software. There's no charge for any of the other or any of the resources to go with it. They're all included in the cost, so there's no further cost for those.
Thank you. Steph asks, will you be bringing Python and Scratch with simulators?
Yeah, we'd like to. Yeah, that's a really good question. I think we're not far off that. Scratch is more difficult because of the way it works, but the Python simulator is on its way and would be really good to have. We've got a timeline of things we're moving on all of these things, and it would be really great to have a simulator for Python. The Scratch one probably is possible in some way, but we haven't got there quite yet. But it is, I mean, I suppose the nature of our business is that we make money through selling the robots. We don't make it through the simulations. Yeah.
I think you did touch on this earlier, but can you just clarify for Anita whether it's possible to use the software on its own, or do people have to purchase the physical robot too?
No, you can use the OHBot software without having a robot, so you don't have to buy the robot at all. You can use the software by itself. So that's this application here that has a simulation, and there's one for Pico that works in the same way. So that's completely free, and it's a full version of the software. It's exactly the same as you get with OHBot, and that's completely free. So there's no charge for that. And then the simulation does everything that, well, not everything, but it does almost everything that that OHBot, the real thing, does. Obviously, it's not as much fun as having a physical robot. I should also say I haven't mentioned the eyes, and we added one thing that we felt it was okay to have one thing that was sort of superhuman, and so we do them with eyes that change color. So you can, if I just make it do, it's a bit scary in red. I'm sorry about this. There's a, oh no, and they've gone green. That's interesting. So let's try that. There we are. So you can program the eye color, any color you like, really. And with Pico, you can change the eye shape. So there's more flexibility with Pico's eyes to make it blink or wink, for instance, because you can also change the robot's the shape of the robot's eyes, which is, again, it's a superhuman quality that the robots have. We thought it was okay to have one little thing like that.
There's a question from Oliver regarding what age group would you use this for? That's a good question, isn't it?
Yeah, it's a really good question. We've always been sort of talking about age 7 and up, and I think as it's based on Scratch, it relies on a sort of a bit, level of understanding of number in order to be able to make it do anything. And so, yeah, we always sort of think about sort of perhaps, yeah, from about age 7, so key stage 2 and up, and we're finding that quite a lot of them are going to secondary schools, and you can do some really quite complex and create some really quite complex behavior using even using the Scratch, the block-based app. You can see that we can work with lists, and we can work with our own variables, as well as all sorts of options around sensing. So it's possible to do create some really quite complex behaviors using it.
We've got just a couple of minutes left, Dan.
Yeah.
So we'll try and there's so many questions, I'll try and get through a couple more. One of the attendees is asking whether Pico can be coded through the app, and also could you explain how the coding that you do on the app is applied on the real OHBot?
Yes. Well, let me just put Pico back on, because Pico works in exactly the same way as OHBot. So it uses the same. Let me just restart. Let me just bring.
If you turn your main
Pico
screen,
back in,
you'll be able to see the robot be larger again. Thank you.
Yeah. I'm just going to bring. So let me just. I'll leave it there. So yeah, so the app works in exactly the same way, and you can control Pico in exactly the same way as you can OHBot, just using blocks. So a head turn block will move Pico in the same way it does with OHBot. So we've made it as consistent as possible. If you've got one, it'll work. If you started using the OHBot app, it'll work in the same way on Pico, and the programs can be opened in either too. There was another question. The other part to that question was about, sorry, could you just remind me, Wendy?
Yes, so how the coding that you're doing on the screen, how does that connect with the robot itself?
It connects simply via a wire. So
yeah.
It connects directly to the computer via a cable. So the program, as soon as you run it in the program, it changes, it will make the change on the robot. And so in this case, you can see here that as soon as I press space, the robot responds in that way, and that happens live in real time, which means it can also respond to other sensor information. For instance, if I was to put a loop like this around here, and now I can like this, then I'm following the position of my mouse when this runs. Sorry, I'll just make my Pico a little bit. This light is very bright. It's fine to see it, but it's there we are. So you can a loop like that will just run live. It's following the position of my mouse, for instance, and I could set that to any other variable. Is that okay?
That's fantastic, thank you. Just echoing Steph's words, who said it was a fantastic session, just to say a special thank you, Dan, for presenting this afternoon, and thank you to everyone who
really enjoyed it.
Yeah, it's really, really interesting, thank you. Please share your highlights from today's session via social media and the CAS website. At the end of this webinar, a short survey will appear on your screen, and we'd be really grateful if you could take a minute to complete the survey. Additionally, in about a week's time, you'll receive an email with your CPD certificate confirming your attendance at this session. A recording of the webinar will be available on the CAS website in the near future. Coming up tomorrow morning, we have webinars on preparing leaders for an Ofsted deep dive, creative computing with P5.js, and tools and strategies for teaching programming at Key Stage 3. Please do continue to spread the word about the first ever CAS Virtual Showcase. Thank you so much for joining, and I hope to see you next time.
Okay.